Hi there! So today we're going to program a MATLAB convolution. So this would be the example one that I have in my video. So it talks about the discrete signal processing. Alright, so before we start, I'd like to emphasize this quotation from Tokugawa Ieyasu that says that let thy step be slow and steady, the thou stumble not. So I love this. So that's why we will going to analyze the slow and steady so that we would not stumble. Alright, so let's begin. So let's dive into our problem. So the problem would be this. So at this point you should know how the convolution programming works, or the convolution formula. So this y's of n. Alright, so we have this problem. Make a MATLAB program to determine the convolution of hn would be this value, and then x of n this value. So regardless where x of 0 and or h of 0 is in the given values, plot the resulting output, as well as in the number 2. This time in the number 2, we compare a result by using command MATLAB command, or the inbuilt function conv h of x, plot the resulting output. Alright, so basically what it means is we should make a program on the convolution and how the convolution works, and then just compare it to the inbuilt function of MATLAB. Pretty interesting, huh? Alright, let's start. So in this example, I've used simpler number and also lower size of array, so that we could breeze through analyzing of the convolution programming and how it works. Alright, so as you can see, I did not include negative, and also the highest number that I have would be 3. Alright, so since MATLAB cannot recognize x of 0, so it's always a must that we start with 1. This. So MATLAB cannot recognize it. So recall that x of 1 is equals to 1, and h of 3 would be equals to 0. Alright, so I hope you know what h of 4 is. So if not, we will be having a problem about that. Alright, now we're going now to use the convolution formula, this one. The first step is to flip this. So that's why in our analysis, it would be important that you have an understanding on the convolution, and you should know how to process when this array is flipped. Alright, so without further ado, let's start at our code, at our analysis of code. So we're going to analyze it first, then we're going to make an algorithm, and from that we're going to make a code. Alright, so that would be the nice process. So at n is equals to 1, x of 1 times h of 1 would be this. Alright, so equals to 1, then add. Alright, seems pretty, huh? Seems pretty easy. Alright, so we're going to increase the iteration, since we have to know the range. At y's of 2, so this would be the result. So 2, x of 2, this one, times 1, this one. Alright, so first element of h and the second element of x. And then the second one is the first element, and then the second element of h. Alright, so at this point, we should notice two things. First is notice that every iteration x index start at the value of n, and h always start at x at 1. Alright, so you can see n is equals to 1, so it starts there. So at this, it starts with 2, and then h will always start at 1. So it should be our task to know when to stop our code and when to stop the loop. So that's also the goal of why we're having this analysis of convolution. Alright, the next step would be this. At n is equals to 3, so this is the results. So you should know on how to get this. So in this, x of 1 times h of 3. So let's go back. The first element of 1 and the third element, this. So they are convolving. So as you can see, it would be this and this. Okay. If we add that, that would be 5. So that would be the value of y sub 3. Alright, so at n is equals to 4, something different happened. Because by instinct, the program would be x of 4 and h of 1. And x of 4 is empty. We don't have the fourth element. So we should have a way that do something because it will return an error since x of 4 is empty. And the same with this at n is equals to 5. This one is empty, so we should ignore this. But this time it's different. The one that has an empty would be also 5. So it has the computer would planning to process this, accessing an empty element from the x element and also accessing an empty element from the h, interfering this right one. Alright. Okay, so in this point we should have a separate limiter for x and h. When I say limiter, this would be the time where the program will ignore and continue in this processing this one. Alright, because not all the index and the size of x and h are the same, so that's why we're having a separate limiter for x element and then h element. Alright, so I did not include the values here. It's up to you to pause the video and then think of it. Alright, also at n is equal to 6, I did not write those ignored part like this, because at this point you should give it a try and then pause the video and then think on the elements that is ignored. So as you can see, it's just 1, so it's expected that at n is equals to 7 there would be everything would be ignored. So that's the time when the program should know when to stop. So the question is, what would be the value regardless of the size? Because if we're going to have a limit of 7, that would be only true for this array, for the size of x is equals to 3 and the size of h is equals to 4. So I've analyzed and concluded that the size of x, or the element within, plus the element within the h minus 1 would be the number of iteration. So regardless if you have 10 there and 20 here, it should work. So meaning it could process this kind of problem. Alright, so the question would be so far, what if x of n and h of n has the same number of elements in the array? So if you run the same analysis that we did, it will still fall to the size of x plus size of h minus 1. You could go ahead and try it for yourself to see that this would help be true. In any case, you'll be satisfied of this. So it is expected that we have this kind of output. So at twice of 1, you could see that we have this, and at the last element 3, this. Alright, now we're going to have the algorithm. So the algorithm would be this. First, initialize the array, execute the for loop, and starting point is 1 and the ending point is the size of x plus the size of h minus 1. Starting point is 1 because we cannot start at 0, because at that point the MATLAB cannot recognize or access the element 0. Alright, when I'm talking about the outer loop, what it means is this. So at n is equals to 1, at n is equals to 2, at n 3, 4, and so on. Alright. When I'm also talking to the inner loop, I'm talking about this part, this part, this part, and this part. So as you can see, that's a lot of stuff. So it should be iterated every the outer loop is executed. Alright. So there are three important notes here. That note that the iteration will be depend on the value of n. So this one. And then observe that the pattern of x and index and h index, we already know that. So this one. And ignore what should be ignored. This one. Alright. So that would be the characteristic of the inner loop. So the inner loop would be the much trickier of them all. So the next would be the sum and increment n. So now let's go to the MATLAB environment. Okay, so let's start. Okay, so to start, I've prepared the code, but I will just copy it, paste down here, and then analyze it slowly. So as you can see, this is my function name, and it would be resulted to y. So as you can see, I've initialized it all 0 depending on the size of h. So it's expected that it would have a size dependent on the input that you have. Also, the summation is for from the name itself for the summation. So I've already initialized it for the effectivity and the efficiency of the program. Alright, so the next thing to do would be this. So this would be our outer loop. So as you can see, the starting point is 1, just like we've mentioned in our algorithm. Increment of 1, and then the size would be this. Or the limiting point or the time where it would stop would be this. So I've already said this in the video. So just to discuss briefly the algorithm that I've used. So for example, if you have a value of x of this, and then a value of h this, and then execute size x, the element of x, and then the dimension that we are specifically referring to. So that would be 3, this one. Alright, so that would be if you wanted more information, you could just type health and then size. Alright, okay, that's fair enough, that's easy. So we understand that the index of x should always start at n, meaning this. If we are processing 4, it should start at 4. However, it's ignored. That's why we go down to 3. So as you can see, also with h, it starts at 1. However, it's ignored. So it should start now with 2. So we should work on that 2. Alright. Now, we're going to start with the inner loop. Alright. So again, the inner loop would be the iteration. Or, just to repeat, this one. This one. Okay. So let's start with the limiter x. So meaning, if it has a value of 4, in my example, this, it should have be ignored, or we should immediately reduce the x index to 3 so that it would process this one. Alright, and then continue, meaning start again another loop. Alright, I'm sorry, I forgot to have the inner loop. Alright, So I'm sorry about that. So for inner loop, we will start with one iteration, and then the maximum would be the number of n. What what it means is just this. Alright, so assuming that we have an n is equals to 3, meaning it already executed this 3 times, the outer loop, so it should have a maximum iteration of 3. Alright, so that's the meaning of that. So if you have 4, you have maximum of 4 iteration, however, it would be this one which should be ignored. Okay, and the index should start with the maximum or the b. And when I'm saying that is this. So when n is equals to 3, it should have the index of h. The index of h would be start with a 1. So it should starting with 1 and then to this. Okay. Or increment depending on the number of iteration. Okay. So let's continue. So it's the x limiter. Okay, next is the h limiter. Beware of copy pasting because sometimes we can produce error, but I've already checked this. So rest assured. Okay. Okay. Sounds good enough. Alright. Now the second. So this is the limiter of h. So remember that I've said that the order is important and critical because if we swap this two. Alright, meaning it would terminate the program without decrementing the value of index. Okay. Okay, and the next would be this. So as you can see, I just closed this part, so that's the rule. And then another end. The MATLAB fixes it for. Alright, the next would be to add the sum using the sum function. So you could check that. Alright. And then we should initialize it to 0 so that we should always start at 0 because if we do not, it's going to pile up on this one, and we do not and we don't want that. All right, and after that we're going to display the y. So it's time to start the program, but first let's save it. All right. Okay, I've already initialized the x and h, this one. So we're going to use the conv function. We're going to place it in our variable name conv program, meaning the one that we've programmed. Alright, so as you can see, it would be this one, 1, 3, 5, 4, 2. Now let's compare with the MATLAB inbuilt function. So because of this exercise, you should effectively know on how to be able to use properly. As you can see, it's the same. So now the real problem would be trying to check out the our previous problem. Alright, so we're going to use this, so that would be the real deal. So let's see. we're going to initialize again. That's it. Initialize the x. So this value would be just based on the problem. Alright, so now we're going to use the same function, the function that we just created, this one. So ready? So let's start. As you can see, that would be the result, and the result for the conv programming would be Matlab. Yes. Alright, so we're going to check it out. Okay, so this is our Matlab result, and then this is our result. So as you can see, when I switch it out, it's look the same. So we're just going to check. Okay, 9. It's the same. Alright, so for the last number, it's still the same. Perfect. So it seems that we've successfully carried out or have the correct algorithm. So that's it. Bye for now and have fun. Good luck. Bye bye.